All right, guys, let's get started. So here's my summary of where we're at so far in terms of looking at our code pictorially so far. So this is a visual representation of a node with data, next, and previous. This is a visual representation of a linked list with the nodes connected and also a head and tail reference. And up here I have UML diagram of a node class and our current linked list class. I know it's probably hard for you to see from where you are because it's quite a ways away, but all the methods are listed there, all the properties are listed there in a UML diagram. And you guys remember what this arrow meant in UML? Anyone?
Inheritance?
Not inheritance. Not is a.
Reference.
No, it's the has a relationship, right? A linked list has a node. It's not inheritance. It's just association or usage, right? So it's not like the linked list extends node. Linked list just uses the node class, right? So it's just using it. Inheritance, you may recall, was that empty arrowhead we drew there. Okay, now, moving ahead. Let's think about arrays. Let's go back to arrays for a second, and let's think about things we can do with arrays. So I go int array equals new int, say size 100. Okay, so our linked list, we can make a linked list. We know that. We don't have to worry about the size because we can automatically add new spots as needed. Whereas with arrays, we got 100 spots, but we couldn't go beyond that 100 spots. And if we weren't using 100 spots, it was a waste of memory. So the linked list is already better. But here's something we can do with arrays. We can go array spot 2 equals 43. Okay? We can set a spot, right? This is us setting a spot to be 43. Or if we use fancier terminology from our last unit, we're mutating a spot. We're changing a spot. We can also do this. We can say like int x equals array spot 4. This isn't us changing a spot. This is us retrieving a spot or getting a spot. We're getting spot 4. Who remembers the fancy name for that one? If this one we're mutating it, this one we're accessor. Right, we're accessing a spot. Okay? So we can't do that yet with our linked list. We can't mutate and we can't access. Now I don't want to write those names as method names because they're too fancy. But we're going to use these names, set and get. Those will be perfect names for our linked list. So that's what we're going to start with today. I'm going to start writing those methods within our linked list. Okay, let's get started. Making some space here. I don't know what's going on out there. You guys out in the crowd. Some kind of craziness going on there. All right. So let's start with a public data type T method called get int index. So this method is supposed to say, hey, give me spot 4, and it'll return whatever data type is stored there in the linked list. That's why it's a T. We don't know what data type it'll be. So we're going to get spot 4 from our linked list. Okay? This is actually going to be easy because we've kind of already written this code. But we can automatically make it a little bit better than arrays by building in an error check. If, oops, in range equals false, oops, that should be a double equals. Well, wait a minute. If the number I just asked you to get is not within the range of my linked list, I shouldn't crash. I should stop right here, but I have to return something. I'm supposed to return data type T, but what can I return to indicate that it's not there? No, because that's not a data type. That's like an integer, and we don't know what the data type is going to be. Not void. You're close. You're in the right. Null, right. Let's return null. Null would indicate that it's not there. Okay? Null is a special value that can be used for purposes like this. If it's not in range, let's just return null. Now, if it is in range, let's return. Okay, and again, you can put the word else there if you want. get node at that index dot data, pull out the data, but we have one last thing to do, and that's, we mentioned that yesterday. We still have to cast this thing into data type T. It has to be cast into T right at the moment it's being returned, just to make sure that it's the right data type, and that's because we're using generics here. If we weren't using generics, we wouldn't have to do that. So that allows us to get a spot in the list. Okay? So it's basically just a two-line method. If it's not in range, return null. And I want to just shorten up this code a little bit as well. I think you guys would be okay with this. This is an easy one to miss, though. Equals equals false is often a lot of writing, a lot of typing. So sometimes it's easier to just go to the front of this if statement and just put the not symbol there. Okay? That means not in range, okay, by putting that not symbol right there. But again, I didn't want to do that right away because it could have been an easy one for a lot of you to miss that. But that actually shortens up the code a little bit. Not in range. Okay, let's test this. Let's go back to our collections test. We don't have a get node feature? Yeah, we do. You're thinking of the morning class. It doesn't have that feature yet. These guys do. Okay? So these guys absolutely got the get node feature. Now, if I ran the collections test, and I'll run it again, you remember what we did is we had two lists going. Well, actually, we had three lists going. We have a list of strings, a list of doubles, and then a copy, which we then added to, and shows that they're not equal because that one. So let's use that copy, and let's try and get one of the spots. Kitten, 7, dog, juniper. Let's try and get that spot, which is spot what? That'll be 0, 1, 2. Let's try to get spot 2. So let's go here and go, after our if statement, let's make a string called value equals copy dot get spot 2. And then we'll output that value. Okay? So here's where we're attempting to test our code. We're saying, hey, get spot 2 for me in that list called copy, and then store it in value and then output that value. And let's see if it actually outputted the right thing. And look at that. It's outputted the word dog. And if we think about it, this is spot 0, spot 1, spot 2. It did exactly what we wanted it to do. But while we're here, why don't we test it a little bit more, just by changing the number. Let's get spot 3 and see what it does. Juniper. Perfect. Okay? So it did what we asked it to do. It got juniper. Get spot 1. 7. Yeah. And now let's get spot 0. And kitten. We've now tested every spot in our list. Let's go beyond the edges, which if we did with arrays, we know would crash. But let's try and get spot 5. We know there is no spot 5. There's not even a spot 4. But let's try and get spot 5. And it didn't crash, which is good. It just gave us a null, which if we wrote into an if statement, that's really handy that we know that, well, the spot we tried to get wasn't actually there. Okay? So that gives it a little bit of an advantage over the array. Notice I can even put in -1, which is a weird number to get, but it compensates. It handles it. If we were dealing with arrays, that wouldn't happen. But because we are in control of this class, we can write a little bit of code to make things a little more powerful there. All right, back to the linked list. That's our get method. Okay? Let's write a mutator method or a set method. Public. Let's make it a Boolean method. Do you remember why we did that yesterday? What was the Boolean return type used for? Why couldn't we just make this a void? Well, we could make it a void, but why are we making Boolean, Peter?
So you know if you actually set.
Yeah, that'll determine whether it was a successful operation or not. Now for set, we're going to need two parameters. We're going to need the index, the spot we're changing, and the new data that we're changing it to. So we're going to give it two parameters. I'm going to say, hey, change spot 4 to be the word potato or something like that. Okay? So we're going to change a value, set it to be a new value. Okay. Here's how we're going to do this. The first thing we need to do is find the spot we're changing. So what I'm going to do is make a reference to that spot by doing this code. Node current, we've seen that before, equals get node of that index. So what current will do, according to our get node method, is it'll find that spot in the linked list. But what happens if the index number is bad? What does get node return? No. So one thing we got to check is if current equals null, that means we didn't find this spot, and let's return false. We can't perform this operation. We can't set spot 500 to be the word potato. There is no spot 500. So that's a little error check to make sure that the index number we're trying to set is within the list. Now, if it's not a null, well then we can just say, hey, current dot data, you are now equal to the other data, and then we'll return true.
Hey, Riley, you won.
Oh,
Aaron, you finished up. What time is it?
all right, so now, again, if we just take a look at where we're at, we now can do what we did with arrays. We can create an array, or like a linked list, and we can change a spot, and we can access a spot. We can get a spot and set a spot, or at least that's what the hope is. We haven't tested set yet. Let's test set now. So we just, in our collections test, got spot 2. Let's change it. Let's say copy dot set spot 2 to be a new, give me a new value, a new string, a new random string, please. How about, sorry? Smelly? Okay. So now we've changed spot 2 to be smelly. Let's output the list again. So let's S out our copy list, because we've been changing the copy around. So let's output copy again, and hopefully we see spot 2 has been changed or mutated into its new value. So let's play that. And sure enough, look at that. Spot 2 has now been mutated. It was dog, and now it's a smelly dog. Okay? But we can test what's called edge testing. We should test more than just this, right? That's your typical case where someone just picks a spot that exists, changes it to a reasonable value. One edge test we can do is these two edges, right? Like what about the first and last spot? So what if I change spot 3 to be smelly? Would it actually hit the last spot? Yes, it would. What if I change spot 0 to be smelly? Yes, it would. So I've tested those two edges. What else could I test? I've tested the typical case. I've tested the two edges of the existing list. What about outside the list? What if I try to set spot 10 to be smelly? There is no spot 10. If this was arrays, at this point the code would crash, but it doesn't crash. It just doesn't do it. Now you notice the list is left unchanged. We also know that this is actually returning the value false at that point. So if this was inside of an if statement, we could then pop up a message box to our users saying, oh, you know, I can't do that, right? But we don't need anything that complex. You could also test the other edge. You could try checking spot -5, which also should at least compensate. So that's more complete testing, actually testing all the different spots to make sure that your code handles all those scenarios. Okay? All right. We've got accessors. We've got mutators. Let's quickly just put in a couple simple methods now. Public T front. And with that one, public T back. Okay? This is basically what's the first spot in the list, what's the last spot in the list. This is a one-line method. And if I use the method I just wrote, I can say, hey, return get spot 0. And with this one, I can say return get spot length -1. Ah, could I do that? Could I return head and could I return tail? Is head data type T? No, it's not. Head is a node. And no, you'd have to say head.data, to actually pull the data out. You could do that, yeah, because head is private. We also have a method called getFirstNode, which is a protected method that we could call in here. So I just want to show you that there are several different ways now that we can kind of look at our linked list. So you're right. One of the other options for getting the front would be, and I'll just write it underneath, to return head.data. That would work. We could also return getFirstNode.head or .data. That's right. So for these lines to work, I would have to cast it as a data type T, this one and this one. Okay. So again, you kind of, as a programmer, think out the options here, which is the best kind of option here. Now, just a sec. Let's think about possible error scenarios. If this was an empty list, would any of these returns cause a problem? Both of these two would actually crash it because head would be a null, and I try to pull data out of null, it would go nope, crash. Would it? What would it return? Well, no, this wouldn't return null. It would crash. This one won't crash, but it will return null. Yeah. Okay, so that's why I would suggest the get method there, because it's got built-in error checking built into it. All right, so that's where we'll stop for today. Don't forget to hit that no, what is it I'm supposed to say? Don't forget to smash that subscribe button, and I'm doing no, I'm not doing anything else after that.